Okay, so I'm going to run a quick video here on how to do the chi-square analysis. This is critical for one of your assignments, your assignment 4, but it's also good to know how to do it. It's probably the simplest analysis we have. Now, I've been told that by some students that the free downloaded version of SPSS may look a little different than mine, and but the principles are the same. So let's just focus on how we do this. So a chi-square analysis is what we call a cross-tabulation table. It's a table that includes two different variables with different different values in the different cells. So if we go to our analyze command and go to descriptive statistics, we can find cross-tabulation. So that's where we want to start. Now I have some data in here. I'm just going to reset this. So you'll see that you have rows and columns. So I can choose, say, a specific variable that I want and test it for significance. So it's usually in just our way of doing things. We tend to have predictors on the rows and outcomes in the column, outcome variables in the columns. But whatever, you can do whatever you want. Say but here I'm not thinking of a predictor. I'm just thinking of a relation between two different variables. Let's say 2 levels smoking, which is a binary variable. I'm going to have that in my rows, and let's do a person's biological sex in the columns. Obviously, sex can't be predicted by smoking, so that's I'm violating that rule right away. If I just hit OK here, let's see, I hit OK, I should just get a nice cross tabulation. So you have, for instance, 143 females who did not smoke, 33 who did smoke. So this is your typical cross-tabulation table. It shows there were 389 individuals in total, how many missing values there were, and there were 4 missing values, so there would have been 393 individuals. So that's a start. So you can see this is the table we need. And so let's go back now and let's add the chi-square. Now in the chapter, when we go to the chi-square, you'll see that you can calculate this by hand, and it's quite interesting how the similarities and what SPSS can do for you. So we're going back to descriptives. Oops, that's not what I want. So let's go back. We go under the descriptive tab right here and go to cross tabulations. So we're all set up now. All we need to do is ask for our statistics. We pick the chi-square. So there's a variety of other stats here that we could do, but we're not looking at any of these. We're just looking at the chi-square. So hit that. By the way, if you want, you can get all the values that you need for a regular calculation. Like you get percentages in the rows column, percentage going down the rows, right, across the rows. You can get expected values. That's something that you actually need in the calculation. All right, cell counts, whatever you want. But let's just do this and run it. And here we see that we get some results. And it tells us with the Pearson chi-square, so that's what we're using, the Pearson chi-square. The only other test that you might ever need here is, well, I'm not even going to get into what a likelihood ratio test is, but the Fisher's exact test. So this is like using this binomial that we did and making a calculation. So, but we don't need that right now. There are times, though, when you do want to use that. When you have small cell counts, but it says here, look, there's 0 cells, have expected count less than 5. If we had some, you'd probably want to use the exact test. But it says here that our chi-square is 0.124 with 1 degree of freedom, and our p-value, this is the probability of a false positive, this is the probability of our observed result given the null hypothesis is true. So p-value stands for the probability of the observed result given the null hypothesis is true, is 0.725. So that's far from being significant. If we set our alpha at 0.05, this is way larger than it. So this is not significant. All right, now let's try one that is significant just so you can see the difference. I'm going to do another descriptive. So I'm going to do cross tabs. I'm going to reset this bad boy here. And let's do, say, smoking. And you can also drag these values in here. So smoking and alcohol use. Yeah, people tend to drink and smoke. Okay. And our statistics, let's do, again, chi-square, and let's run this and hit OK. So now again, we have a different table because there were more levels of alcohol use, 0, 1 or 2 days. And you can see there are some cells that have less than 5%, less than less than 5, right? So you could actually argue that there would be better tests for this, but our sample size is quite large here. Actually, I probably would break this down into a smaller data set, like I'd probably do 0, 1 or 2 days, 3 days or more, something like that. But I'm just trying to show you the chi-square statistic here. So here we have 51.353, and our p-value now, our p-value is less than 0.05. So if our alpha was set at 0.5, we have 6 degrees of freedom here too. So the cells are, it's rows -1 times columns -1. That's how we get the degrees of freedom. And our p-value is 0.0. So it means it's very small. It's less than 0.001. So we would definitely, in this case, reject the null hypothesis. Null hypothesis is that there would be no relation between alcohol use and smoking. So that makes sense to us, okay? So that's how you run the chi-square test. All right, thank you very much.